Hello. I thank you for inviting me. I previously apologize for my lousy English, but the good news is that if it were in French, it would be a lot worse. So, I've been working all my career fundamentally in the water distribution and water supply systems, and in the last 10 years me and my company, we've been working a field that is very important for Portugal, that is the losses, the water losses in the networks, water supply and distribution systems. Portugal had a major crisis, and that was an opportunity to don't spend the money you don't have. So okay. So that's a brief bio of me and the company I founded 10 years ago. And the only thing that's really important is I'm founder and general manager. So in Portugal, the water losses are in level of, the level is 30% of the volume, and as you see in red is the zones, the municipalities that are above the limit, nearly all country. In terms of potential reduction, we have more than 100,000 euros per year if we reduce the losses. In Portugal, the relation between the type of losses are like you see. The real losses are the great part of the losses. The apparent losses in the flow meters and depths are important too. The three components of the losses are the unbilled authorized consumption. We must put flow meters everywhere, try to bill everything, and change land and soil uses. For the matter of the pets, this doesn't change because it's mainly a commercial loss. The apparent losses are commercial too, so for the purpose of PATs, it isn't important. But the real losses have an important role. So the first thing we do to decrease the real losses is the sectoring, dividing the net in DMAs, district meter areas. Why is it important? Because, as you see, you can't find Waldo. If you divide the net, it's easier, and then you find Waldo. So the network must be divided in several pieces so that we can find the problem. The components, where do I point? This is a scheme from Mr. Farley, where you can see the DMAs and the closing of the valves. The components of real losses, the first one is pressure management. In the networks, we must have a lot of pressure. The maximum in Portugal is 6 bar in the network, and you have to have a pressure sufficient to the people. So if you have three buildings with five floors, you have to give 3 bar. So the window is very short. But in Portugal, nobody applies the law, so there's a lot of municipalities with pressure and 10, 15 bar, which is impossible to control. This is the first step to downsize the real losses, is the pressure. The second one is the proactive leakage control. You can't go to the net and find any leakage. You must, before of that, you must have the DMAs and then go to the right spots. If you don't do that, you'll be like this all your life, solving problems in the mole and get old. So this is more scientific and better results. The other thing is important is to know what you have. You can't manage what you don't know. So it's important a geographic information system with an important information. The important information is not only the obvious as diameters and length and the material, but also intersections. For instance, valves closed, what are their settings, and so on. And in Portugal, this is very difficult to obtain. As you know, in Portugal, there is no great organization. An important thing also is the speed and quality of repairs, which is very important to get people very happy, so they work. Here, the revenue of the water is about 20–25% of the non-revenue water. So, where do I point? Oh, okay. So, in this point, we have the possibility of an energy recovery. But this is the goal of the Portuguese law, 15%. We have 40%. So, as you see, the real losses are the biggest component and the one that, for purpose of using PETs, is an enemy. So, you have less flow, you'll have less energy recovery. So, now we have 40% of losses. Is an opportunity to start quickest you can, because if the leakage goes down, you have less flow, you have less production of energy. All the problems can be an opportunity, and this is one of those cases. For instance, in Nepal is the distributor at Lisbon. They were always at the same level, 25, and then they implement this kind of solutions, and in 1 year they passed 27 million to 23, 14, 19, and so on. They had an investment of 2 million euros, and they got back in these years about 50 million euros. You can see every year, for instance, from this 8 to this 26 is 18 million cubic meters per year, comparing with the starting point. So it's an investment, it's a very good investment. It's a comparison of Lisbon with other major cities, just to do a lot of propaganda of my country. The first thing a municipality asks us is, and my money, is it profitable? In 3–5 years, we can do the ROI. I love the word ROI because it's my name in English, the return of investment. And you can add to this energy recovery. The great economic investments components are there. So, the common framework, the starting problems. We have hydraulic problems, we had bad operation, lack of rehabilitation, no DMAs, etc. We have in Portugal a big drama in the water system. So we have a high level of losses. In Portugal is about 30 to 40% global. And Portugal has this problem currently. 94% of the country is in drought. So this shows the importance of these problems, to solve these problems. Okay. The base problems is the information, the geographic information system, the client info system, the modeling, the hydraulic modeling, and so on. It's a work that requires many time of work, and we have in Portugal a difficulty to obtain data. We have a human resources problem, know-how, lack of staff, but we have a bigger problem, and that is the open mind for change and innovation. In Portugal, we have a situation that that is the main problem, is fado. The Portuguese national song is the song of the fatality. It was always like this, it will always be like this. So, and they have poems, fantastic poems like this. And that lady died very sad. Other problems we have, the malfunction of the systems of water supply. There are no control, no flow control. In this example, I asked Kemi to put the little video, please. She doesn't like me.
Mas eu estava, ela cá tem que pedir uma coisa para ligar aquilo ali. Isto é muito bem.
Por favor.
Não, mas eles já está ligado, mas eles já deviam ter ligado isto.
No.
Eles ligaram cá dentro.
Sabotage. In Portugal, there is a lot of problems. This is one of it. Well, oh. Okay.
Isto é muito bem.
Can you play it back, please? I pressed the wrong button.
Já está ligado, mas eles já deviam ter ligado isto. Eles ligaram cá dentro.
Here. Oh.
Mas eu estava, ela cá tem que pedir.
That is the top plane, the surface discharge. And they are using the reservoir as a chamber for dissipating energy. It's unbelievable, but it's true, as you see.
Cá tem que pedir uma coisa para ligar aquilo.
And
isto é muito bem publicado. Não, mas eles já está ligado, mas eles já deviam ter ligado isto. Eles ligaram cá dentro.
So the problem is to control. Oh. This is the front view. You can't go to the chamber of maneuvers because you get. It's always winter there. So we don't have any control at the entrance. And if they control the entrance, the net explodes here. So we had to make two zones, two separated zones, and control the pressure and control the flow. So we have the big buildings, small buildings separated by two separated zones. So this problem is also an opportunity. Other situation that we have there, I won't show any video, it's difficult, is when we supply the lower reservoir, they don't have any water in the higher reservoir. So they don't control anything. So once again, we have opportunities. I stolen from Elena, about stone, confessing my robbery. And this is an opportunity, because not only the flow is the total flow of the area, but we need to control the flow. So it's an opportunity for our good friend Pet. In Portugal, the situation is, here you have the slope, we have the great slopes in the Northern Territory, the Serra da Estrela, and so on. And the division between Alentejo and Algarve. I hope you all have been in Algarve. We need tourists. We are in bankruptcy. Here we are. We have some experimental situations in Covilhã because the Serra da Estrela is 2,000 meters. And Covilhã is a few hundred. So we have a great potential. Is now being developed the project, pilot project of recovering that energy. As you see, the big consumption, the big density is near the sea and Lisbon and Oporto, and we have a situation is curious because I made this chart. Is the above 95% of the buildings here in red are 1 or 2 floor buildings, which means it's not necessary to have such a high pressure in Portugal. In Portugal, we have about 5 bar in the network. It's not, and we have punctual places with 10. It's not logical because we only would need in the majority of the country up 2 bar. What, 2.5, 3. In Lisbon, is limited to 3 bar. If you want more, you pump. The consumption is the same situation per kilometer. You have here, Alentejo is a very dispersed situation, but is a great concentration of people in the major cities. Well, okay. Here is the losses I told you before. The major part of the country is in red. The real losses, that is important losses for the purpose of recovering energy, because the other are purely commercial. This is real. And the ELI, the infrastructure leakage index, is the index that you can see that is in Portugal. We have in the places that we think it were very good, like this one here. It's not the same. You can't go to the same conclusion. It's different if you use another index. So, okay. The dangers of this index. The jumping of conclusion, you have a part of this system that has no consumption without supply, and this says, so this is 50%, and this is very good, no losses. But if you lose a drop, it will be 100% losses. So we would say, this is awful, this is marvelous, but it's not true. This index must be must have a choice, a fundamental choice. That is the case you have, the index you have. You must use the same index for all situations. If you see, if the volume of losses is the same, you have, for instance, 50%. If the bill of rice consumption variation goes up to 50%, you have 40. But if the bill of rice consumption, if the people consume less, you go to 68. But the losses in volume are just the same. In Portugal, after the crisis, people spend less water, so the percentage goes up, which is good. People in panic is very good. One important thing is reliability of data. And one of the things I always talk about this information are valves, areas, and T's, because this is in English. VAT is a tax. In Portugal, in my presentation, is IVA. I made a little change because it's important, and I use this VAT because it's a tax, and everyone, deaths and taxes are inevitable. About the losses recovery, if we have the level of losses of 30–40%, if we can go to 15%, we will the country will change its colors, as you can see. And the recovery volume is illustrated, and the economic revenue is here. So in this image, you can see where are the more valuable kilometers, which means where you should attack, which are the municipalities that are in worst situation. This was an exercise, numerical exercise that I made for this country with this presumption, these basic assumptions. The turbine would work half day, 50%, and so on. And if we do this, we would have about 700 million watt-hour per year. This is a global estimate, and this image shows where are the places that we would produce more. As you can see, this would produce more because of the slope, and here because of the consumption. Unfortunately, in Portugal, where we have the great slope, you don't have the great consumption. But a case in I've been working is Madeira. Madeira is a singular case, not really the common case. It's the exception, but it's a good exception, as you can see. First of all, great climate, great food, and Cristiano Ronaldo, for start. The airport of Madeira has a bust of Cristiano Ronaldo, and they rename it to Cristiano Ronaldo. We are working in the pilot zone, one pilot zone in Funchal. The pilot zone here represents about 40% of the total of the territory of Funchal. And in Funchal, we have this is about 800 meters, 19 pressure level zones, 106 pressure reducing valves, 140 head loss chambers, 42 reservoirs, no DMAs, so no Waldo. The average slope in Madeira is 56%, the pilot zone 23% average slope. So it's a very, very complicated thing. In all Funchal, we have 65% losses, 18 in 27 million cubic meters a year in losses. It's unbelievable, but it's true. So we have here great opportunities of work. If you don't work, you can play with the bust. So, in the Funchal, the pilot zone with 5 reservoirs with different levels, and the level about 400 meters the difference between the levels. In the pilot zone, you have this situation here, 75%, and it's crazy. We have a situation that the setting of the valves is practically always wrong. This is the setting that should be. This is the setting that it is. So we have great pressures, and they put more pressure is the solution, as you can see. And why do they do this? Because they didn't study the net. So if you have a problem of low energy here, and you have like this the energy line. So if you build a building like this, what do? Get the pressure up. But the problem was not the valve. The problem was the tube, the pipe, that has a great head loss. So they don't solve the problem. They came with a scheme to solve. And the head loss here, the unit head loss, above 5 is only the blue ones. So the other ones, the red is 20, above 20 meters per kilometer. It's crazy. It's impossible. It's unmanageable. So we have to solve the hydraulic problem. This is the situation of the pressure. The red is above 60, 6 bar, which is illegal in Portugal. The black, these zones, are above 10 bar, which is much more illegal. So 50% of network is illegal. Average pressure, 5.5. And here, 98%, except for the main city with hotels and so on, but the majority is to level buildings. So we have an hydraulic problem. We made 30 DMAs. You see for the various colors. This is the current situation. As I told you, this is the modeling, the hydraulic modeling with EPANET, because it's the cheapest one, and everyone has it in the old municipalities. And in the future situation, the works are starting. Will start this year. The future situation is the one I show here. So there's no red points, no bubbles, and the pressure drops about 1.6 bar in average terms. So there are zones that the drop of the pressure is about 3 bar and so on. At short terms, the losses level will turn to 61, and in 15 years, the annual reduction will be 6.7 million cubic meters per year. So, once again, this is the situation, the average situation, the pressure reduced valves, the head loss chambers, and the future pressure reduced valve, 50 valves. We'll put 50 valves in the system to reduce and transform the situation. We could potentially produce this energy in this concrete situation, this real situation. And the big three, the existence and the future, have these flows and head and pressures. If we concentrate on this big, we made an experiment with KPSB PET, and as you can see, there is a problem. with the reducing of the losses, the flow gets smaller in the other case. So the efficiency of the PET is very important because we don't have, as in the transmission and supply systems, a constant flow. The flow is decreasing. So the high level of losses creates an opportunity, but is an enemy because it's turning the flow down. Here we made an experiment with variable speed, or in the first year, but 15 years later, the production is a lot less. If we use constant speed, the production, the daily hours of production goes down and down and down, because the efficiency along the way is getting down. So this one was this one, and now this is this. So in this case, we have only a difference of 40%. So each case is a case. You must study everything, model, and so on. Which ones to choose? Here we have all of them, and with a quick glance we can see the valves and the annual energy. So we can, if we put this in percentage, you have here important conclusions. With 10% valves, we can produce about 50% of the potential energy. With 20% of the valves, 70%, and so on. So when we say the potential energy is X, we must see that it's not profitable. The lowest flows and the production of energy is not profitable because you have to invest a lot of money on the machine and so on. So we have to concentrate on the most important ones. So in conclusion, with this technology, I'm quoting Obama, yes we can. And so this is exactly, we must, in Portugal we are very, very, and this is an important contribution to sustainable development. So I end with an ancient American proverb, which is very important nowadays. Thank you.
Merci.
Est-ce que vous avez quelques questions? Profitez que les...
Do you have any questions? Yep.
Bah, simplement savoir la différence que vous faites entre perte.
So what is the difference between actual losses and apparent losses?
Pipes. Huh? Okay. The real losses are the losses in leakage, in pipes, valves, and so on. Apparent losses are the losses you have in the error on the flow meters and in the thefts, the robberies of water. They are not real losses. The water is not lost. The water is there. It's a commercial loss.
Oui. Des mauvaises mesures, quoi.
So wrong measurements. Hey, intervention. So
Ah oui, d'accord.
Merci beaucoup.
Ah oui, c'est le Portugal, d'accord.
That is Portugal for you. So we're going to be taking just a quick review session. Handing it over to Professor Elena Margarita Ramos from Portugal. He's been teaming up with Hernando, sitting on this technical committee in the hydraulic studies and engineering side of the project. So thank you very much indeed. Thank you to our distinguished chair.
For language, more or less in simultaneous. Well, so if you don't mind, since the English is the official language for this project, I will make my presentation in English. Well, this is a little bio from myself. I am a professor in the University of Lisbon in the Instituto Superior Técnico. This is the Faculty of Engineering of this university. I have some publications, some historical regarding the hydropower solutions, pumping systems, pump storage, renewable solutions, hybrid solutions, leakage detection. It's enough, okay? Well, giving you a brief overview of this presentation, I would like to start with sustainable development. It is a quite current slogan, okay? It is very important to consider this. And water, as we know, is the core of sustainable development. Since it enhances living standards, expands economies, creates jobs and social inclusion, poverty reduction, green economy, towards this slogan. Well, for this, you need to think in terms of pressure reduction valves, as presented before with my colleague, an expert in this subject. You need to in any water distribution networks, we have, as we saw, different pressure reduction valves. They are used to guarantee the standardization and control of pressures. As we can observe here, this is a scheme of this DMA. This is a district meter area to control some levels of pressure in our system, dividing the water grid in pressure areas according to the different topography. The maneuver of a pressure reducing valve creates head loss. And if you look at the characteristic curve of a valve, pressure reducing valves or control flow valve, it is quite similar with the characteristic curve of a turbine, or a pump-as-turbine, or any type of energy converter using water. So this arose in my mind in 1999, okay? And when I presented or I talked about the use energy converters in water systems, water pipe system in water sector, using pump-as-turbine, it was not well received. But now you are in conditions given by the former presentations too by the France technology. It was very interesting to make this connection between the different overviews in terms of scales. We start with a big scale, come to medium scale, and now you are also in a micro scale. Well, here, this is a resume based on the data given by my colleague, Roy, okay, in English, Roy, yes. But it is interesting to see the consumption versus losses, okay. Here we can see the real losses in the authorized consumption like this. In average, we have more or less 25%, okay, grossing, in a grossing analysis through the whole Portugal water municipalities. Well, here we can see the energy consumption in terms of the energy for water pumping, for other activities, for example, treatment plants, and the energy production, the energy used by the electric grid and the own energy production. It was put only in this circle. Okay. Here, only to give you an idea about the number of reservoirs, we saw different schemes how to benefit this type of energy converters applied in the water sector. One of these possibilities are associated to reservoirs. We saw in different presentations here, and it is important to know, this is for Portugal, of course, and giving an idea about the EPAL. EPAL means the system that manages water in Lisbon, that presents a very low percentage of water, depending on the year. Okay, my colleague is much more updated. And of course, this can give us an estimation based on the average values of the 39 PRVs. PRVs means pressure reducing valves, okay? We can estimate approximately this value for energy production in a water distribution system. We have a guarantee discharge flow along the day, along the year. So why not to introduce this and to take these benefits, this advantage. In Funchal, Madeira Island, as presented before, we can estimate this value or more, considering more the others, not only the suggested 50 PRVs, but the others. And in idea, it is the manager of irrigation system of Alqueva. It's a huge system that has different investors, foreign investors there. We can estimate at least 20% of the total energy consumed in this system can be produced. Here it is the distribution in terms of energy production in Portugal for renewable energy systems, different types, different kinds of renewable energies, and of course the large hydro, it's very important. Most of them localized in the north of Portugal due to the topography, as we saw. And another important solution is the wind, and we can integrate this, not looking at separately energy sources, but integrate some of them and transform these solutions into hybrid solutions. Why not? I think it will be the future in terms of energy production solutions. In terms of energy recovery, we have a lot of type of turbines. Okay, different turbines for high heads, small flows, medium binium, or high flows and small heads. Okay, we can cover these diagrams with different type of machines. If we are looking at a pump working as a turbine, we can observe here the different possible solutions, including the multi-stage, PETs, radial, mixed, etc. Well, we can apply hydropower schemes in water supply systems. We are talking about this. It's important to see the critical points in order to preserve the minimum pressure in all the system. We need to guarantee a minimum pressure all the system when we have the pipe along the ground. It is important to analyze along different hours because we have consumption of water which varies along the day. It's very important, and it implies different pressure along the day. We can combine this with a storage tank. We can combine hydropower schemes. I think hydropower schemes is very versatile. It's very flexible, and we can combine with different components of the water sector. For example, looking at water treatment plants and industry, we can use this. Following, for example, these values obtained by the EU27, the total number of wastewater treatment plants estimated as this number, so for which we can estimate a total energy consumption very huge, this value. So why not to produce energy to help to reduce this energy consumption directly in these places. Another scheme can be combined in drainage systems. We can create some retention ponds, and why not to control the floods using these retention ponds. That it is very interesting because, for example, in Lisbon we suffered a lot when there is intensive rainfalls. Intensive rainfalls near the river, it's easy to create problems of floods. Okay, but Lisbon is very beautiful, okay? Don't be afraid of this, but you need to consider, for example, solutions like these, retention ponds, to produce energy in a controlled way. Well, another combination can be with irrigation systems. Irrigation systems are systems normally not pumped, okay, and have guaranteed flow in a big part of the year. Huge quantity of water is used, and we can use in these systems in order to produce energy. We developed some tests in lab for different hydrants in order to obtain an estimation of this. Well, it is important, the investigation too. The investigation is important to know the behavior or to predict the behavior for different operating conditions, since the manufacturers does not give us this information. They want to sell the machine, and we need to know all the operating possible conditions that can introduce some disturbance in my systems and can induce burst of the pipes, for example. Well, it's important to know there is already proposed functions for radial PET and axial PET based on the affinity laws developed by Professor Carraveta and other research team worked together in this. And in REDAWN, okay, you need to land in our project in REDAWN, and in REDAWN we intend to construct 3 pilot plants. Okay, one in industry, in Renova. It is a company, a paper manufacturer company in Portugal. Another one, it will be in irrigation district in Córdoba, Spain. And another one, it will be in France. It will be in France in a water distribution system. Okay, these systems are different one from the others in discharge variation, in pressure available, etc. And it is important to have some guidelines for different types of systems in order to be possible to apply much more confident this type of solution. There are already some applications, but since the project are focused on this in the water sector, let's try to evidence the problems and the benefits of application of this. Well, here it is a brief presentation of this water industrial processes of paper manufacture, which this company is focused on the innovation and the efficiency in order to obtain the best productive solution. We can observe there are two manufacturers, okay, 1 and 2, near a river that pass by both. Water is very important. They make the capture of water in the river. Okay, here we can have an idea about the consumption of water in a manufacture too. This is the machines you used for paper manufacture, and here we have energy consumption associated to this. So it is an ideal site to try to produce an energy to compensate the energy consumption used in this manufacture. Okay, this is a quite small example. We have some measurements already. We can estimate a power of quite small but interesting, a 10 kilowatt power installed for a flow variation between these values, 15 and 50 liters per second, with an available head at the wastewater, okay, for this river, Almond, around 30 meters. It is an interesting project, like a small hydropower project with a long penstock. This is the draw of the penstock with the levels signed here. And this is a view of the outlet discharge underground past this street and have to attain the river down at the bottom. This is the outlet flow of this manufacturer. There are already some control in terms of the quality of water, in terms of the levels in the river. This is a possible draw of our penstock implantation. Here it is the river Almond in a quite dry season, okay, after the summer, quite dry season. Portugal had more than 10 months without rain. It was very, very big crisis here regarding this, but it is important in terms of the variation of the flood. We have to take into account different variables, okay, in each study. Each case, it's different from the other. Here it is a possible pump working as a turbine, okay, considering the minimum maximum flows with an efficiency around 80% for the point with the best efficiency. Here it is an interesting search in terms of the availability of type of energy converters to be used in any type of pilot station. We have another one regarding the irrigation system in the district of Andalusia. Okay, the central office belongs to the Palma del Rio in Cordoba, and we know the characteristics of the system, the pipe diameters, the type of materials, etc. We are in conditions to simulate using the APANET, for example, to simulate the conditions along the year, since the flow varies along the year. Here you can see some views. There are pumping station. We can use part of the energy production in the gravity systems to supply, to feed the pumping station. Here it is our grid, and the behavior of the network is represented here during a certain duration, okay, showing the pressure in the nodes. We can see the pressure in the nodes with different colors. Excess of pressure, as we can see, are red too, okay, Roy, okay, are red. We are consistent. And the flow in the pipes. In the pipes we can see the colors. Well, for any type of study we need to make some approximations. Several possible locations were analyzed, and the second one was one very interesting, since it is the manager's location and the destination of the energy recovered, such as, for example, for batteries to charge electric vehicles in the future, electric lights, air conditioning, etc. Okay, Another, here it is a scheme located in the system, has a bypass. And the source analysis, source possible location, since as the second one, it is in the same place, but includes another pipe branch with different characteristics. And we can estimate, using a scheme, different schemes for different solutions, we can estimate the best power for our system. And we can see the net head, this is delta P, the net head obtained in our system, and the correspondent discharge flow. So in this irrigation system, it is a bit different from a water supply system or water distribution system. It is important to know how a PRV operates as happens in a water distribution system, and if the introduction of a turbine can make the similar functions in our systems, locating our turbine, replacing it or not, or is necessary to put together with the PRV in order to guarantee a minimum pressure when we have no flow in our system. Well, another one, it will be here in France, in Granville, SCMPGA, Syndicat Mixte de Production d'Eau Potable de Granville et de La Branche, and we can see a possible location for our small or micro hydro. This is why I'm talking about micro-hydro, since there is here a pressure reducing valve to reduce pressure. To reduce pressure, let me see, okay, between around 12 to 5 bars, okay, at upstream, amont et aval, upstream and downstream of the pressure reducing valve, so that can be used to be transformed in energy. Yesterday you saw the manhole where there is a PRV, and that upstream you are making some, actually we are making some measurements, some registrations of pressure and flow in our system, in order to be possible to understand how the flow vary along the day, and the pressure are associated to this flow, okay? And we can choose in the best way the micro solution. For example, in this case, since the flow is quite small and the available head is very high or medium, okay? It's around 70 meters. We could use, looking at the availability in terms of a pump as a turbine, working as a turbine, maybe it is necessary to consider a multi-stage, multicellular pump, or 2 pumps in series, etc. We need to analyze the different possibilities in order to optimize the energy production. Okay, and that's all. Thank you very much for your attention.
Merci.
Any question?
Oui, alors, pardon. Oui, c'est bon. Oui, mais la question c'est...
The question is, well, globally, I'd like to take a step back, because I assume, as those two presentations were about Portugal, the two are interrelated. But earlier, I didn't ask the question. Earlier, we looked at the losses in the network in Portugal. And it seems that if there's a loss, it's because there are leaks. So the first thing is not to work on pressure, but to actually work on the pipes. So what I would do would be to first change the pipes or repair them. As, well, your presentation was about energy recovery, I was wondering whether I'd understood everything.
Funchal. The zone is about 200 kilometers net, and we change 12 kilometers pipes. The problem in the pipes were solved. We can't have those pipes with 20, 30 meters per kilometer of head loss, unit head loss. But
Ah bah oui, mais c'est quand même la priorité.
But it's still the priority.
Non, le traducteur fait, mais avec un léger du...
I may try and speak French, says he.
word translation, but the case in Funchal, we had about 200 kilometers net. We have 200 kilometers net, and we change about 12 kilometers of pipes. So the pipes that were making great head losses, who had great unit head losses, were changed. So the first thing is to put the system in a correct hydraulic work, independent of PRVs or so on. First thing, we can't have those situations. So the solution was a hydraulic solution. The changed pipes, connections, new lines, creating also district meters areas, and so on. But in Funchal, as we saw, Funchal has a slope, average slope, a big average slope, so has zones with high pressure. But when we change a pipe, who provokes a great head loss, the pressure would be greater in those cases. So we need also to have a global look of the system, because if you have a pipe who provokes a head loss, a high head loss, unit head loss, along the day the pressure varies immensely, and it is the situation that we have a lot of pressure in one point and lower pressure, not sufficient pressure downstream.
Bon, écoutez, d'accord, mais...
Right. Put on your headset, please. Nevertheless, if your network is not waterproof, is not watertight, you've got to make it watertight. It is the most basic thing to do. If you realize that in a network where you've changed 6% of the pipes, 12 out of 200, that there's still more than 30% of losses, is that your network is not satisfactory in terms of water tightness. So the priority is to make it watertight and use funds, credits to make it watertight. And then, secondly, possibly, you may work on the excess pressure. This is what I wanted to say. To supplement, I think what the Portuguese speaker wanted to present is that there's a dual effect. When you change the pipes, obviously reduce the leaks, but there's another opportunity, that is, if you work on pressure in addition, you improve even more the efficiency of the system, and the impact is also financial. A leak is always a loss of money, and it's even more so if the pressure is high. That's why it's a double approach to optimize the hydraulic network. If I may intervene, I think there's a confusion between load losses, head losses. So it's not exactly the same thing as the network losses. the head loss is related to the resistance of the pipes in relation to the flow of the water, and the loss of water is related to the leaks. I thought you were talking about the leaks. That is, in the drawings we saw, it was water coming out.
The confusion between head losses, okay, and water losses. Okay, head losses, this is due to the friction of the pipes. Water losses, it is due to leakage, orifice and ruptures of the pipes. Right. But I'm sorry, but I'm very quite optimist, since it is. Sorry, but it is preferable to do not.
J'ai
To
pas
do,
parlé de choses.
no.
Je parlais
In some cases, we, in some cases, we can less a certain level of water losses because it is not economically there is not economically advantage to repair them, okay? But we can compensate these losses producing energy. It is very interesting, this, okay? Of course, if you don't have any losses, we can produce energy only when we have consumption of water. But in some cases, it is not, there is not any advantage in terms, it is not feasible to repair all until to attain 0%, because there are some slices and some settlements, etc. It is important to control all until to obtain the 0 water losses, but we can see in the otherwise, we can benefit with this. Why not? During the night, we can have some leakage, but we can produce energy and compensate this. It is an open mind in terms of the manage of the system, okay, of the system. It is, we need to balance all of these components, all of these variables.
May I add a point? Of course, pressure reduction as a strategy to reduce leakage is something that is used in many countries where we are old networks. But all our systems have been designed in the 70s, probably before the 70s, with the level of pressure in the tanks that are very high compared to the actual necessities. So if in our countries it's necessary, it is possible to reduce pressure, because in this way we have a reduced leakage, the pressure can be contained in all countries, because the level of pressure that was granted in the 70s, in the 60s, is not the same level of pressure that is necessary now. So a better control of pressure can be a possibility of producing energy, even if there is no reduction of leakage that is connected with this better. I mean, we need that the pressure level is constant in all the network, and not that we don't have so high differences in pressure. And this can be done everywhere.
Yes, you need to have an integrated view, not only to look at water, but integrate energy also in these systems. Water energy nexus, it will be fundamental.
Okay. J'ai 2 objections à faire.
I've got 2 objections to the way you see things. The first one relates to your potential resource. If you've got the resource to compensate the loss, good.
0 costs. It is available. So the leakage attained this value.
Bon. Et la deuxième,
And the second is that, anyway, the matter of the aging of the network, well, the thing is, it's not going to improve, obviously. So what I'm saying is that is taking a step back to finally jump further away.
discussion.
Juste pour répondre, je vais le dire en français, je trouve que
It's not contradictory. You may calculate the potential and estimate how you could recover, how much energy you could recover, even though the priority may be to replace, to change the pipes. But then when you do it 2 years later, when you change the pipes, you integrate the cost of the micro-turbine. Yeah, then that I agree with. I think you'll have a difficulty to understand one another for two reasons. Regarding the hydraulic profile of Portugal or Spain or Italy, the hydraulic profiles designed in the 60s did not plan for build of the same level of pressure at the bottom of the buildings. So it was necessary to have high pressure for 10-story buildings. In France, when you want to build a 10-story building, now you need to have an overpressure station at the base. So the base in France is 3.5 bars for the highest story, because washing machines and all designed with safety systems. If the pressure is too high, it stops. That's why you find it difficult to understand one another between Portuguese and Italians, is because we don't have the same hydraulic profile. And yeah, I understand you when you say you first work on the part where you've got the most leaks. But by rethinking the hydraulic system and with overpressure station at the base, it will compensate the variation in pressure with turbines that can produce energy. Because I think the misunderstanding comes from the fact that you don't talk about the same thing. I understand what you asked for, but you've got to, think of the point of view from the point of view of the Portuguese or Italian colleagues, and in Spain it's got to be the same. I've got to insist, though, because the two were related. What bothers me is that the two are related. You take advantage of a leak to recover energy. If there's no leak, then, well, the issue of recovery imposes itself. If you've got a high slope or overpressure, you have energy to recover. Yeah, but they've got to rethink their hydraulic system in all they do today. We don't need to do that when we change a network. We don't change the hydraulic profile, but they don't have a choice. And I guess it's not easy. Those are heavy works, and it shouldn't be easy to manage. And well, a network of 200 kilometers, I understand how many millions of euros it represents. So please, the partners of the project, would you please come back on the stage, and members of the audience, do not hesitate to ask questions so that we can communicate at best regarding what we're going to do in this project. It's got to be clear in your minds. You've got to understand what we expect from you, why we invited you today. Yeah, we talk about your projects, etc., but it's about getting to understand how you will be able to contribute to the success of the approach with data, recs, feedback, so that the whole sector can adapt itself to finally get to the right destination. Maybe we can ask all of the speakers to come back on stage.
As you want.
So, any general questions from the audience that hasn't been covered so far? Eric? Oh.
Yes. Do you know already some pump manufacturers who already gives their characteristics for a pump as a turbine?
Go ahead.
Okay. Well, there are few because the manufacturers are much more concerned until this last year, until today, this year, the pumps operating as pumps. But for example, I consulted Caprari from Italy and KSB from Germany. I consulted for specific cases. It is very difficult to obtain several characteristic curves that we can choose for different places. Each case we had to consult them, and they give after several insistence, okay? If not, they can only point out the type of pump as turbine that they can sell. But since I am researcher, I'm trying to get characteristic curves for my investigation. Without them, I have some difficulties. Also, we test some of these pumps in our labs, in our university labs, to obtain and to analyze the behavior of this pump working as a turbine. But these two manufacturers that I mentioned can give, because they gave me some information after some insistences. If we intend to build a system like this, they are interested.
And do you believe them when they give you the result, or are you? Do you have to make a verification?
I think that, let's say in the last 5 years, probably, or if we went 5 years ago, you mightn't get that information. But I think today, those two pump manufacturers that mentioned have tested all of their pumps in reverse. And you can buy a pump as a turbine and pay a little bit more for the certification of its behavior. From KSB at the moment, anyhow. And probably as the market grows, that will become more common.
Oui. On parle de pression.
To talk about rather high pressures, and the idea is to have a rather constant pressure all along the network, considering the head losses related to the length of the network. So why not have brushless motors with adapted wheels? Don't know whether you know them. They've got a running profile that goes from 0 to 100%, and they consume only the power necessary to meet the needs. It means there aren't important variations when a pump is activated and you've got a consumption profile that is lower. That's first thing. And second thing, if it's possible to have the main network a pressure that is rather low, just like the president of SMPGA said, at base and with multicellular pumps, with broachless motors that regulate the pressure in adapted sectors and regulate the flow. Don't know whether you know the systems. It doesn't seem to be the case. Broachless motors are coded wheel motors that can go from 0 to 100%. That is, the motor doesn't reach 100% of potential right away. They consume the necessary power.
Changing somehow the supply system of the network, and instead of having a supply from a fixed level to pump water to the system with variable flow condition, in order to have the pressure as low as possible. If I understand well what you are proposing. This is a possibility, but of course it will change the working condition of the network, so it is an evaluation that you have to make between the two possibilities. So the one, but I mean the PAT, so the energy recovery in this case is a factor that can be important to evaluate if it is possible, if it is convenient to change, because the excess of energy that you have now can be partially recovered. So you can put this cost as a positive, an income, to be added to the negative cost that you have now to pump to a fixed level, and compare the cost of actual supplying with the energy recovery to the cost of supplying water with direct pumping by changing the system, supplying inverters to the pumps. So in the evaluation of the system, you can make this kind of change. So change the supply to have a lower level of energy use, but you can evaluate between all the possible strategies, and of course this is a big problem that engineers have in the different network, because the solution is different from one case and another. We are making something smaller. We are simply saying that if you have excess energy, you can recover this energy and you can produce energy, and we have an income. So this is an element to be put in a strategy that you can do in any network to reduce, to increase the efficiency of the network.
Voilà, je suis d'accord, bien sûr, sur les réseaux existants, je suis parfaitement d'accord avec vous.
I fully agree with this statement, and then we only consume the energy that's necessary to meet the user's needs. That's the end purpose.
There is what happens if the electricity is gone. In the case of a pumping to a high level, if the electricity switches off, you have some water for a while. Whereas direct pumping relies on the pump always to work, and it doesn't always work. So there are other things aside from, you have to consider the reliability of the system as well as the energy costs. So if it's working fine, okay, but sometimes we have emergencies.
This is the same problem that we have when we make districts, for example, because one of the strategies to increase the efficiency of the system is to isolate, like our Portuguese colleague told, to isolate part of the network with the same pressure in order to level the pressure. But of course, this is a good strategy for efficiency, but it reduces the flexibility of the network. So if you have a damage in some branch of the network, the flexibility of the network is lowered probably sometimes compared to the other. So you have to act with opening the system, so it is important that you consider that the functionality is important. So if you can make everything, but you must be sure that the system is working in emergency. So it is a matter of the water manager, of the water utility, to find the best solution. We find pieces of solution.
Oui.
Good. There's something I'd like to highlight. We've been considering this energy recovery issue on a global level, at the European level, but every case is a specific case. So we cannot consider the system, let's say, in a mountainous area with significant waterheads with pressure delta that are way beyond the 10 bar or even the 100 bars, as in the case in some of the regions in Portugal and regions, flatter regions like our region where we are today. And where we get pressure delta that can be related to, well, we're probably talking 100 meters with water towers offering the pressure delta of 15 bars, and that's the maximum pressure that you can just get, and on a very ad hoc basis at that. So when I prepared this meeting, I wanted to consider what was possible to do, to what could be done within the SMPGA. And now I would like to continue with our discussions within the framework of the SMPGA, given where we are, our profiles, maximum heights, and other such parameters. What I'm going to tell you is not going to be necessarily welcome, but my standpoint relates to the study I developed, which is not that enthusiastic from the point of view of the SMPGA territory. Right, there may be energy in the networks. That's obvious. That's an obvious statement. There is energy in the networks. If to some extent this energy is required to operate the network, that's obvious. Yeah. And we can recover part of this energy, maybe. It depends what part, so as not to imperil or endanger the functioning of the network, at what cost. So there's the cost of the installation, the repayment of the loan, and the maintenance cost. And it is by balancing out all of these factors that we can assess the viability of the project, because you don't want to recover energy just for the sake of recovering energy. So if we want to recover tiny quantities in view of the investments, clearly this is not going to be a great solution, even if from the point of view of good conscience, we'll have saved some energy, right? So I do want, not necessarily now, but I'd like to put a discussion, to really discuss my analysis, and far from me, it's I'm not reaching the conclusion that investment in this scheme would pay off. What you're presenting is of great interest, because you're talking about the challenges of the case. That relates to profitability, viability, and the potential. And correct me if I'm wrong, there's the topographic grid, which is a natural ground where a network is installed with pressure deltas. So at SMPGA, we are here on a kind of flat land, but we have a couple of pressure reducing valves, and with the exception of Avalanche, where there's a small hills that brings in a natural head. We have other regulating valves, and operated by the local operators, and at times we have to pump to distribute water to reach the required pressure, and then depending on the position on this network, the one just right next to the fast pumping, well, might end up with an overpressure and over availability, and those at the end of the line might end up with a non-availability. So there are different ways of approaching this, and the actual definition of the potential has to take into account the topography and the analysis of the existing network as it is built and with its defects and the potential of potential for energy recovery. And this is a point. We can't question the whole existing infrastructure. We want to go forward, we want to move forward, and we want to leverage what's good and to give it the best value possible to get an ROI. And that's the third parameter, which is the economic parameter. And that is exactly why we're here today, to achieve a good ROI for this type of technology, which are emerging technologies. This morning is safe, Monson and the likes delivered a presentation. But some of the operators have, some of the OEMs have delivered their analysis. Some have proven ROI, others are just, it's early days. And it's, it's like the stellar road. Well, as such, right, we're not there yet, but what's interesting is the disruptive approach. And what we want is to create a market so as for people to have a greater interest in that. And operators know how these work. OEMs can deliver the manufacturing potential, but the market is really early days for the market. So this is, but I like to apologize for, most of you are not involved in the management of SMPGA, but I have very concrete, very practical questions. Mr. Taibor, Mr. Cavaret, what is currently, in terms of forecast, the cost, the energy cost, and cost in euros, forecast for the operation of the pump? What is the total cost? So the total ownership cost of the kind of idea or ideal that would be about working at break-even point, or we'll have to have the minus and the plus. So what would be the cost energy-wise and in euros? I think it's not the way you should actually approach this. You need to look at the hydraulic profile, because in the past, every organization was autonomous, and going forward, will redistribute the distribution parameters of water networks within the territory. So we, in the past, we had to supply such and such heads of network, and now the point is to put the pressure up once and then to recover energy in the system from the one reservoir head and not from several, because every time you send water to a location, I'm going to give you a simple example. Let's take a reservoir at Granville, and we sent a first one in 1,000 square meter tarpaulin retention pond. Then this is sent back in a distribution to the network, and we resupply a reservoir to regulate the pressure. So the profile that we're now working towards will be directly from the 1.1 heads and back or into the entire network. So the energy will have had a cost, an initial cost, but we'll recover this cost on the network. And to quantify this, the hydraulic studies would have to be analyzed, covering the entire territory. So the energy costs involved to run the pumping equipment and water plants would have to be taken into account, but this is about optimizing the network. Instead of having 3 sources of supply from that one source, so we can work on a full hydraulic mapping so as to, and we're not going to install, we want to install energy recovering units if there's no use for those. We'll have to break even and so get return on investment. So we can start from a maximum calculation, because the purpose of the SMPGA is to get the same network operating at a lesser cost. So if you're telling me that what the operating cost of the network, it's a starting point. It's minimum. There's a minimum and maximum point. If we can't get a profitable a calculation, this is highly pessimistic for the situation going forward. So do you have some ideas of this current operating cost on a yearly basis? So for the moment, we do have annual costs, but I'm not going to give you figures. I think we're talking about 80,000 euros per year for energy for the first facilities. That of Marjorie, I don't know exactly. So by and large, I'd evaluate it between 130,000 and 150,000 euros of energy spent in power, so electricity. Just a simple kind of basic approach, but we do have small capacity production units that are quite expensive in terms of running cost, and we want to redirect the production to the main units so as to bring down the cost of energy and the operating cost. It's not only about energy, but the processing products that need to be taken into account.
Je dirais. Donc, aujourd'hui, si on travaille dans l'intérêt, je dirais,
So energy-wise and environment-wise, we need to take into account all of these factors. Fully understand your question. Today, it might be early days. That was not the point of our talk today. What we wanted to really find out today was about all the methods that could be implemented, and maybe we'll share ideas with our European friends as to methods and ways of doing things. But today, we're talking about the early days of this research initiative. Maybe we can meet up again in a year's time and see the progress made. And depending on all of these, we might not, change the whole system radically. But networks have to be designed in totally different ways from, we're talking about an enlarged and extended territory. We can use the experience of our friends so as to avoid duplicating, things that have been done on other networks. So we have many, many things to look into. Distributions, there's recovery. So as of the 1st of January 2018, it's only been 2 months. So we're starting to work on all of the factors, but I'm fully aware of, not building in overcomplicated systems if this is more costly and if this doesn't contribute to the environment. The purpose here is to save kilowatts as a whole. If we can get to a neutral point, that's great. And I think we're sharing the same mindset. Well, I'm totally reassured now. I had become concerned about the system, thinking, well, are they really aware of the fact that things are not that simple? I'm going to give you an element for you to compare, to draw the attention. I must be talking about 130, 150,000 euros.
Donc on arrive à la descendre à autour de 100 000 euros.
Let's imagine bringing down to 100,000 euros by and large, a ballpark figure. This morning we talked about the experience of Annonay. Very specific conditions that I really wanted to point out. Reservoir 500 meters, then municipality located 300 meters away. System works Well, it recovers what was expected. So, do you know what the equivalent of 19,800 euros recovered compared with 100,000 euros investment? So not, I don't want to be the disruptor here.
Dominique, on va être obligé de couper, on est en transmission live.
Apologies, we are pushed for time, so we'll meet up again. So I think we'll wrap up. Yeah, just to reassure you, there's about 30 existing projects here and many others in France, but so it's great for our local authorities to experiment such a project with competence, human resources on hand, so as for the whole of the territory and all our local authorities to do likewise. We're not throwing money out of the windows here. We're making sure that this project is reliable and really makes sense from every respect. And I want to assure you, we have 30 such projects that really are in operations in France. Well, wanted to commit to a similar approach, and they might not be that viable, but you're now talking about, something that really is, from one meter in. Well, you're asking me, so.
2 mètres cubes d'eau à la seconde.
So you might end up with a 2 cubic meter of water per second, or 10, 15. Up to 100 bars of pressure. It's what we've reiterated. Every site is different. Every site is specific. Every site is unique. And you might have many, many responses if you look around with these 30 sites. Apologies, but maybe we are going to wrap up the discussion now. We can continue with the discussion in a different way, but I think we're here with our European colleagues. Anything else? I mean, this is a discussion. We're reaching the end of this presentation. Final point: you all received a small sort of question card. So we'll get back to you to take the time to take these further following this. Launch and see how we can work together, how we can continue working on this project. We're going to be moving on to the closing remarks, and with our project leader to close the event. And then obviously, I'm not wrapping. I don't want to, bring to an end a discussion. This is just the official closing remarks here. We need to continue discussing. We need to continue talking about these challenges and see how, with our European partners, we can come up with solutions to address those issues. Thank you.
Just as the lead partner of this Atlantic Area project, can I say that the last 3 or 4 days have been very busy for all of us. They've been very productive also. But we've been well fed and we've been well looked after. And we've had some very informative site visits. We've learned a lot, and we have moved the project forward, which is why we wanted to have the launch here in Granville. There are too many people to say thank you to by name. The organisers, the speakers, the translators, who have done a particularly fantastic job today, so thank you to them. And thank you. So instead of listing all the names to thank, what I want to say is thank you to you, the audience, because you've given up your day to come here, to listen and to learn about the project. There will be other slightly smaller events in each of the regions over the next 2.5 years. But we're actively seeking stakeholders in this project. So if any of you in the audience wish to become involved in the project, you can speak to Yves. Today has been incredibly well organized. Today has been incredibly important for us at the beginning of this project to learn and to hear how passionate people are about this, which is very important to us. Many of us have got some very long distances to travel home. Some of us are going home to airports which are actually not open, so we don't know how we're going to get home. So with that in mind, I would like to say thank you very much again, and that's it. The project, the launch is complete. So thank you very much.
Merci.